So now our process is running, and it's actually doing computations, handling stuff, writing into memory, and doing all sort of things. But at some point, our process is isolated, and at some point we might want to interact with the file system or with things outside of our process. So here we have our process doing things, and inside its memory, it has the heap, it has a stack, etc. You know the drill. And at some point, we want to interact with the file system, which has files, which has directories, and we want to be able to write or read on them. Or we might want to be able to write something for the user, like use the print function, which you might know of, because it's present in almost all of the programming language you know. But how does any print function actually work? What's behind that? And the answer to that question is actually what's called a file descriptor. So the way this works is the process is tightly linked to the kernel. And remember, the kernel is actually responsible for managing all sort of input-output and managing everything that's between a process and hardware. And that also includes the print function, writing or reading from a file, creating directories, etc. So anything you might want to show to a user or you might want to write into a file, go through the kernel. And the only way you can interact with the kernel from a process is with system calls. So, okay, let's have a look at that. So file descriptor, what is this? A file descriptor is very simple. It's an integer. And that's very important that you remember that. A file descriptor is just a number. And the number is tracked by the kernel per process, and the kernel knows what this number means for this process. There's a couple of file descriptors that are common to all processes, and don't mean they are the same for everyone, but they have the same number. For example, file descriptor number 1 is what's called the standard output, or std out, and you might have heard of that. File descriptor number 0 is what's called the standard input, or std in. And you may have heard of the standard error, which is system call not 3, but number 2. std error. These three file descriptors are open when the process is created and are managed by the kernel. For most programs you are going to write, this std out system call is the console, the terminal you are running your program from. And when you use the print function, it's actually going to use this std out file descriptor. So let's have a bit more look in depth at what's going on. The system call that's used to interact with any kind or to output any kind of data outside of a process to a terminal, to a file, to a socket, we'll see next time, is what's called the write system call. The write system call, you can find it on the documentation in section 2. The write system call takes an integer, which is going to be a file descriptor. It takes some data, which is any kind of data that you want to write. So it can be a string, it can be bytes in general. If you want to write some specific bytes into a file, you can do whatever you want. So let's call it just void pointer. And it takes, very importantly, the length of that data, because it cannot know the length before it starts to write it. So the length of that data, which is an integer. When you call the write system call, for example, when you use the print function or the printf function, which is in libc, the print function is going to call the write system call with the std out file descriptor, and the kernel is going to receive that and actually output and write that on the terminal or in a file or anywhere else. But for std out, most likely in the terminal. Likewise, when you want to input something from your terminal into your process, you're going to use the std in file descriptor. And in the same way you have a write system call, you also have a read system call, which works exactly like you expect. It also takes the file descriptor number. It takes where you actually want to write the data you are going to read. So the void pointer here is going to be where you are going to write this data, and it's going to take the length of the data you read, which is also an integer. This read system call and the write system call are the two most important system calls you are going to see when you want to interact with things outside of the process. And of course, both of them are handled by the kernel and might take different names if you are using a different system. But on Linux, they're just called write and read.